Okay, next question. So we're given f of x and g of x. Part A, it says to find f dash of x. Well, let me write f of x first. So f of x is minus x minus h squared plus 2k. So h and k are elements of, an element of the real number, so they're just constants, so don't let them worry you or ruin your easy derivative here. So f dash of x is, so multiply by the power, x minus h. Don't multiply this out, guys. That you could do that, but it just makes it harder. Subtract 1 from the power, which is 1, so I just leave it there, and the derivative of a constant is 0. So that's it. That's the answer. This is kind of a chain rule, but because it's like 1x, you're just basically timesing by 1, and you get that. So that's nice and easy. Okay, this is where it gets a bit tricky. So these two questions I thought were difficult, certainly for standard level. So it says the graphs of f and g have a common tangent at x equals 3. Now, firstly, what does a common tangent mean? Or, well, what is a tangent? So a tangent is a straight line. So imagine they have this straight line is common, and it's a straight line that touches the curve once. So well, let me try and draw these curves to give you an idea what's happening. So this is a negative quadratic, so something like that. And this is an exponential function that looks something like this. And they have a common tangent, let's say right here. So what this actually means is, this point is on both of the graphs, because they have to meet, they have to intersect here, because they both have a common tangent here. So the tangent means this straight line touches this green curve, which is the exponential, this curve, just once here, and it touches this blue curve just once here, which means the blue and the green curve actually touch each other just once here. So that's important to understand first. Then, what can you say if they have a common tangent at this point? And this point, by the way, guys, is at x equals 3. So there's two things we can say here. The curves intersect, which means when x is 3, f of x equals g of x. That's the first thing. And the second thing is, because it's a common tangent, and this question, it actually starts with find the derivative, it's helping you to kind of hinting you along the way to show that the gradients have to be the same at x equals 3. And that's what I'm going to use first to find this, because I've got the derivative. You could try equating them first and see how you get on with that, but I'm pretty sure we have to equate the derivatives first, because that's the derivatives actually get rid of this k here, and they'll do that for this guy as well. So there's a little bit less going on. So let's do that. Let's do that now. So I'm going to get g dash of x, the derivative of g. So g of x is e to the x minus 2 plus k. G dash of x, because we're differentiating e, is just going to be e to the x minus 2, and again this k disappears. So at, and it's important, let's write this, guys, at x equals 3, f dash of x equals g dash of x, or you could obviously write f dash of 4 equals g dash of 4. So I'm gonna make that equation. Minus 2 times 4, sorry, not 4, 3. So I'm subbing 3 in here. 3 minus h equals, I'm subbing 3 in here, e to the power of 3 minus 2. And what do I want to show? That h equals e plus 6 over 2. So let's multiply this out. I'm going to get minus 6 plus 2h, minus times minus is plus, equals e, because 3 minus 2 is 1, and then 2h equals e plus 6, which means I'll just write it here, guys. H equals E plus 6 over 2. Okay, part C. Hence show that K equals E plus E squared over 4. So again, getting back to this point, guys, they have to, at x equals 3, they intersect. So I'm going to just write here f of 3 equals g of 3. They have to, the y coordinate at 3 has to be the same. So we sub 3 in here. So minus 3 minus h squared plus 2k equals e to the 3 minus 2 plus k. Now remember, we have h, guys. It is e plus 6 over 2. So I am going to, let me see how he wants it. He wants it in this form here. Okay, let me think how I'm going to do this. Okay, I'll do minus, and then 3 minus h. So it's 3 minus h is e plus 6 over 2 squared plus 2k. So I'm actually going to do the 2k minus this k is just k, and that equals e. Okay, so we have our k on the left and we have our e on the right. I just need to turn this into e squared over 4, which I'm sure I can. Okay, let's make this. A common denominator is going to be 2. So this gives me 6 minus e plus 6 all over 2 squared plus k equals e. So that's just a common denominator of 2, and then 2 times 3 is 6. Let me move down a bit. This is then going to be minus 6 minus e plus 6 is just minus e. So this is minus e over 2 squared. I like the way this is turning out, guys, because this is what they asked me for. This is going to be minus e squared over 4, because minus e squared is e squared. Minus times minus is plus, and 2 times 2 is 4, plus k equals e. K equals e plus e squared over 4, which is what they wanted, QED, which means I have shown what was asked. Okay, that's that question. Yeah, as I say, a little bit tricky. The key is to understand that a common tangent means the point is the same and the gradient is the same.